Introduction. Light is something that everyone is familiar with. It comes from many sources, the main one being our sun, and it provides us with the energy needed for life. Without it, life as we know it would not exist. The form of energy which helps us to see objects is called light. Objectives. At the end of this lesson, you'll be able to define light, understand the nature of light, understand the reflection of light by a plane mirror, laws of reflection, differentiate between real and virtual image, light and its sources. The form of energy which helps us to see objects is called light. Light travels in straight line. It causes in us the sensation of sight. There are two sources of light: luminous objects and non-luminous objects. Luminous objects. The objects which emit their own light are called luminous objects. Example: sun, lamp, candle. Non-luminous objects. The objects which reflect the light which falls on them are called non-luminous objects. Example: moon, chair, etc. Nature of light. To know how light reflects, refracts, diffracts, and many other aspects, we have to understand the nature of light by its theories. The nature of light has two theories: wave theory of light and particle theory of light. Wave theory of light. Light consists of electromagnetic waves which do not require a material medium for its propagation. Its characteristics features are diffraction, interference, and polarization. Particle theory of light. Light is composed of particles which travel in a straight line at a very high speed. Its characteristic feature is reflection and refraction. Light exhibits the properties of both waves and particles. Light has dual nature. Reflection of light. The sending back of light rays when it falls on the surface of an object is called reflection of light. Objects having polished surface reflect more light than the objects having unpolished, dull surfaces. Silver is the best reflectors of light. Reflection from plane surfaces. Plane mirror is a thin, flat, and smooth sheet of glass having a shining coating of silver metal on one side. The silver coating is protected by a red paint. Meaning of important terms are as follows to understand the figure. Incident ray. The ray of light which falls on the mirror surface is called the incident ray. Point of incidence. The point at which the incident ray falls on the mirror is called the point of incidence. Reflected ray. The ray of light which is sent back by the mirror is called the reflected ray. Normal. The normal is a line at right angle to the mirror surface at the point of incidence. It is a line which is perpendicular to the mirror at the point of incidence. Lateral inversion. When an object is placed in front of a plane mirror, then the right side of the object appears to become the left side of image, and the left side of the object appears to become the right side of image. This change of sides of an object and its mirror image is called lateral inversion. Characteristics of an image formed by a plane mirror. The image formed is virtual. It cannot be received on a screen. The image formed is erect. The size of the image is as of the object. The image formed by the plane mirror is at the same distance behind the mirror. The image formed is laterally inverted, sideways reversed. Plane mirrors are used as looking glass. They are used in solar cookers. They are used to make kaleidoscope, a toy which produces beautiful patterns from colored paper, pieces of glass, or small colored beads. Laws of reflection. First law of reflection. The incident ray, the reflected ray, and the normal all lie in the same plane. Second law of reflection. The angle of reflection is always equal to the angle of incidence. Difference between objects and images. Object. Anything which gives out light rays is called an object. Images. Image is an optical appearance produced when light rays coming from an object is reflected from a mirror. Difference between real and virtual images. Real images. The images that can be obtained on the mirror are called real images. Example. Images formed on a cinema screen. It is formed by a concave mirror. Virtual images. The images that cannot be obtained on a screen are called virtual images. Example. Image of our face in a plane mirror. It is formed by concave lens. Did you know visible light has wavelength in a range from about 380 nanometers to about 740 nanometers with a frequency range of about 405 terahertz to 790 terahertz. Light which is emitted and absorbed in tiny packets called photons exhibits properties of both waves and particles. This property is referred to as the wave-particle duality. The speed of light in a vacuum is defined to be exactly 29 crores 97 lakhs 92,458 meter per second, that is 3 into 10 raised to the power 8 meter per second. Mechanisms that can produce light. Scintillation, electroluminescence, sonoluminescence, triboluminescence, Cherenkov radiation. Summary. Let us summarize what you have learned. Light is a form of energy which enables us to see objects. Light exhibits the properties of both waves and particles. Hence, light has dual nature. The process of sending back of light rays which falls on it is called reflection. The change in direction of light when it passes from one medium to another is called refraction. The angle of incidence is the angle made by the incident ray with the normal. The angle of reflection is the angle made by the reflected ray with the normal at the point of incidence. The angle of incidence is equal to the angle of reflection. Image is formed when the light rays coming from an object meet at a point after reflection from a mirror. In plane mirrors, there is the effect of reversing the sides of an object, and its image is called lateral inversion. Introduction. As we look around the room, We see most objects by the light reflected from them in order to converge, to bring the parallel rays of light closer, or diverge, to spread out the parallel rays of light. This phenomenon of converging and diverging is done by spherical mirrors. The mirrors having curve-like surfaces are known as curved mirrors. Objectives. At the end of this lesson, you'll be able to define spherical mirrors, understand the types of spherical mirrors, understand the reflection of light by spherical mirrors, concave mirrors and convex mirrors, differentiate between concave and convex mirrors, how to form images, know the sign convention for mirrors, define magnification. Introduction of curved surface. A spherical mirror is that mirror whose reflecting surface is the part of a hollow sphere of glass. Spherical mirrors are of two types: concave mirror and convex mirror. Concave mirror. A spherical mirror in which reflection takes place at the bend in surface is called concave mirror. Convex mirror. A spherical mirror in which reflection takes place at bulging out surface is called convex mirror. Important terms to understand spherical mirrors. Center of curvature. It is the center of the hollow sphere of glass of which the mirror is the part. Pole. The center of a spherical mirror is called the pole. Principal axis. The straight line passing through the center of curvature and pole is called principal axis. Aperture of the mirror. The portion of mirror where reflection of light takes place is called aperture of the mirror. Principal focus. The point on the principal axis to which all the light rays are parallel and converge after reflection is called the principal focus. Focal length. It is the distance between the pole and the principal focus. Rules for obtaining images formed by concave mirrors. Relationship between the radius of curvature and focal length is F is equal to R upon 2. Rule 1. A ray of light which is parallel to the principal axis passes through its focus and after reflection from the mirror. Rule 2. A ray of light passing through the center of curvature reflects back along the same path. Rule 3. A ray of light passing through the focus then becomes parallel to the principal axis after reflection. Rule 4. A ray of light incident at the pole is reflected back making the same angle with the principal axis. Formation of different types of images by concave mirror. When object is placed between pole P and focus F, image is formed behind the mirror, virtual and erect, larger than the object, magnified. When object is placed at the focus F, image is formed at infinity, real and inverted, highly enlarged. When the object is placed between focus F and the center curvature C, image is formed beyond center of curvature, real and inverted, larger than the object. When object is placed at the center of curvature C, image is formed at the center of curvature C, real and inverted, same size. When object is at infinity, Image is formed at focus, real and inverted, smaller than the object. Uses of concave mirror. Concave mirror are used as reflectors in torches, vehicles, headlights, and searchlights. Shaving mirrors to see large images of the face. Dentists to see large images of the teeth of patients. Rules for obtaining images formed by convex mirror. Rule 1. A ray parallel to the principal axis of a convex mirror appears to be coming from the mirror. Rule 2. A ray going towards the center of curvature of a convex mirror is reflected back along the same path. Rule 3. A ray going towards the focus of a convex mirror becomes parallel to the principal axis after reflection. Rule 4. A ray incident at the pole is reflected back making the same angle with the principal axis. Every time the image has following characteristics. The image is formed behind the mirror. It is virtual and erect, smaller than the object. Formation of different types of images by convex mirror. When object is at infinity, image is formed behind the mirror. It is virtual and erect, smaller than the object. When object is placed anywhere between pole P and infinity, image is formed behind the mirror. It is virtual and erect, smaller than the object. Uses of convex mirror. Convex mirrors are used as rear view mirrors in vehicles to see the traffic at the rear side because it always produces erect image. The size of image is small and so we can see a wide field of view of traffic behind. Mirror formula and calculations. Mirror formula is the relationship between the image distance v, object distance u, and focal length f. 1 upon v plus 1 upon u is equal to 1 upon f, where u is the distance of object from mirror, v is the distance of image from mirror, f is the focal length of the mirror. Sign convention for spherical mirrors. All the distances are measured from pole. Distances are measured in the same direction of the incident light is taken positive. Distances against the direction of incident light is taken negative. Distances measured upward and perpendicular are taken positive. Distances measured downward and perpendicular are taken negative. Magnification produced by lenses. The ratio of the height of image to the height of object is known as linear magnification. Magnification is equal to height of image h2 upon height of object h1. M is equal to h2 upon h1, which is equation 1. If magnification has plus sign, image formed is virtual and erect. If magnification has minus sign, the image formed is real and inverted. The linear magnification is equal to the ratio of the image distance to the object distance. M is equal to V, image distance, upon U, object distance, which is equation 2. Equating equation 1 and 2, h2 upon h1 is equal to V upon U. Note, in mirrors, linear magnification is M is equal to minus V upon U, and of lenses is M is equal to V upon U. Power of lenses. The power of a lens is measured by the degree of convergence or divergence of light rays falling on them. Convex lens converges the beam of light falling on it and focusing them to the optical center. It has the greater power. Concave lens diverges the beam of light falling on it and making it less strong. Power of lens. The power of a lens is defined as the reciprocal of its focal length in meters. Power of lens is equal to 1 upon focal length. Important points. The power of convex lens is positive. The power of concave lens is negative. Power of combination of lenses. If a number of lenses are placed in close contact, then the power of the combination of lenses is equal to the algebraic sum of the powers of individual lenses. P is equal to P1 plus P2. The SI unit of power of a lens is diopter. It is denoted by the letter D. Did you know light exerts physical pressure on objects in its path? Light pressure is equal to the power of light beam divided by c, the speed of light. It is written in the Rig Veda that light consists of 3 primary colors. Mixing the 3 colors, they have produced all the objects of sight. Summary. Let us summarize what we have learned. In concave mirror, the reflection takes place in the bent-in surface. In convex mirror, the reflection takes place from the bulging out surface. The radius of curvature of a spherical mirror is the radius of the hollow sphere of glass of which the mirror is the part. The focus of a convex mirror is situated behind the mirror. The image is formed at that point where at least 2 reflected rays intersect. A real image is always inverted and virtual image is always erect. Large concave mirrors are used in the field of solar energy to focus sun's rays for heating solar furnaces. The object distance U is always negative in mirrors. A medium in which the speed of light is more is known as optically rarer medium.